Don Luke Electronics. The Alpha Geek, geeking out. If you go to bed at night without learning something new that day, your day is not complete. Luke Paquin, 1973. Project number 28, Sensors, HC-SR04, Mk12. Pololu 5V step-up voltage regulator U1V10F5. This tiny U1V10F5 switching step-up voltage regulator efficiently generates 5V from input voltages as low as 0.5V. Unlike most boost regulators, the U1V10F5 automatically switches to a linear down regulation mode when the input voltage exceeds the output. Ultrasonic distance sensor, HC-SR04, 5V. This is the HC-SR04 ultrasonic distance sensor. This economical sensor provides 2 cm to 400 cm of non-contact measurement functionality with a ranging accuracy that can reach up to 3 mm. Each HC-SR04 module includes an ultrasonic transmitter, a receiver, and a control circuit. There are only 4 pins that you need to worry about on the HC-SR04, VCC, power, trig, trigger, echo, receive, and GND, ground. This sensor has additional control circuitry that can prevent inconsistent bouncy data depending on the application.
Now the sensor here. The SparkFun zoom here, switch here, Arduino terminal for this here, battery here, date and time here, GPS receiver here, this movement here, up and down, and that's it. And now this side is electric movement here. So this up the ping here and back here. So perfect for the ping. Now sensor here is sensor here. This programming here, switch here, the pins here, and tools here. So Arduino plus here, battery here, and switch here, date and time, GPS receiver here, movement here, and this sensor here. And now the Pololu for 5V here, because this 2 and this 5. So this here for here, and switch here, and sensor 5V. So is good. Now the project here, library here, Bluetooth keyboard here, wire here, here, the date and time, GPS receiver, hardware serial port for here, and the sensor here for movement here. Now the Bluetooth serial here, and here, and size, date and time, receiver, GPS receiver here, and latitude and longitude, and this GPS hardware here, movement here, and gyro this, and attitude here, and the electronic sensor here, switch here, version here, and now the date and time, GPS receiver here, GPS keyboard, gyro here, and compass, and the version here, and electric movement here, and switch, and this good, perfect. 1 second. Bluetooth keyboard here, and size, and write the here, and key. GPS receiver here, and here. Good. So here, first vector here, latitude and longitude. Yes or no. Date and time for GPS 2. Date and time. Same thing. And after, GPS keyboard for here. Perfect. This electronic sensor here. Switch trigger, and this. The distance for the key, the distance for keyboard here. Distance, echo, and time, and the delay here, and back, and time, the distance here. This gyro here, and keyboard here, this same thing here, Bluetooth here, this same thing, and this, and this, and this, and adding pitch and roll. So perfect. Date and time, set up here, and here, and version, and this, and date and time. Set up here, first Bluetooth serial here, wire, date and time, the sensor for movement here, this here for same thing, the setup here, switch, and one less here, and 2 seconds here, and that's it. Now the switch here, and that's good. So the sensor good, and after this sensor here, perfect here, and computer Bluetooth. So this sensor good for the Bluetooth is good because the sensor and the computer perfect. So now this for switch and me the computer and perfect. So this 1 second and wait and another one and another one. So perfect. Now version, and this the project here, and this perfect. So switch here and see. Sensor here. The version, date and time. GPS this the GPS status for GPS here, latitude, date and time for GPS, gyro in this, headings in this, and distance here. And now here, up here, here, and me here. Now here. This good. And back for this the time. Now back here, here. Perfect. Bye bye.
Don Luke Electronics. https://www.jlpconsultants.com/luc. JLP Consultants. Facebook, YouTube, Twitter, Pinterest, Instagram.